We start with the introduction. I'll try to motivate and give some context to quantization. Assuming most of you are working on edge AI technologies and attending this session, I'm assuming that would be easy. Next, we look at a high-level overview of quantization, what it means and how you do it. So you at least have the idea of fundamentals that are involved in quantization. Next, we look at the transformer architecture, the building blocks that are used to make this transformer architecture that you kind of see everywhere now in both text and image and audio applications. And next, we talk about how these building blocks are quantized, different precisions, data types, what kind of configurations that can be used, and what kind of trade-offs that you have to do when quantizing a transformer model. And next, we look at a couple of quantization methods and try to understand what kind of innovation that they bring and what makes them popular, what kind of trade-offs they involve. And when it comes to the results, we apply these quantization methods on popular open source models like Llama and OPT and see how the quantized accuracy looks like. And most of these models are quite popular and widely used. And we conclude with some key takeaways and some insights into LLM quantization. And at the end, we have references. Most of the results that are generated here are using open source tools and open source models. So if you're interested, you can definitely take a look at the references and give it a try. So let's get started. So as you can see, mostly we have a lot of LLMs that are going larger by the day. And while this image might be a little old, I think it still conveys the idea that the AI models are progressing at a much faster pace, getting more bigger models, whereas the hardware, compute and the memory bandwidth are not able to scale at the same level. And while models like DeepSeek tend to reduce the compute, but the challenges still remains because now the consumer wants to run these models on their PCs, mobiles, so they're again competing for memory and compute resources. This is where quantization comes in as a useful tool. It reduces the model size, thereby reducing the memory footprint of the model as well as the bandwidth requirement. Also, it is able to improve the compute efficiency, improve the compute throughput, so you get better frames per second. And one of the challenges with quantization is while you're trying to reduce the model, it tends to introduce noise, quantization noise, which can impact the model accuracy, which is challenging to recover.